So we're presenting right now. Today is September 19th. It's Monday, Math 104. I just mentioned that the quiz grades were posted. And the topics that we're going to be going over tonight would be polynomials and factoring. As far as the polynomials, we're going to be referring to addition, subtraction, multiplication, and we're going to do division. As for factoring, we're going to go into the different, we're going to do grouping. We're going to be doing cubes. We're going to be doing quadratics. So we'll give examples of all of this. This is just like a sneak peek so everybody understands where we stand. As far as polynomials is concerned, can someone just tell me, like, I know I defined a polynomial previously. Can anybody tell me what a polynomial is or what it consists of? What's the difference between a polynomial, a monomial, a binomial, trinomial? What's going on here? Anybody?
A polynomial is a coefficient with a variable.
Okay, all right.
That's a monomial one.
All right,
but you put two monomial, you get a polynomial.
There you go. Good. Exactly. All right. So if I present on the screen, let's say I have 2x, what would that be? Versus 2x plus 2y. What's the difference between the two?
The first one is a monomial. The second one is a binomial.
All right. Bye. And then if I present, let's say I have x squared plus 2x plus, I don't know, I'm making these numbers up here. What is this?
It's a trinomial.
This is a trinomial. Okay, very good. All right, so this is our basic characteristic of what we have. Now, if we're going to add polynomials, or in this case, monomial, if I have 2x and I add another 2x, what would I have? Anybody?
Just 4x. Just 4x.
That's right. So I have a monomial here. I have another monomial here. So this would give me another monomial would be 4x. And the reason why I can do this is because I have the same base, right?
Like terms.
So, correct. Like terms at the same base. So now in a situation whereby now, let's say I have a trinomial. And now I'm going to add another trinomial. I have to do like terms, right? So if I have to do like terms, what gets added together? It would be this monomial with this monomial, this monomial with this monomial, and then the last one would be this one, right? So this is my first, this is my second, this is my third, right? I can't mix and match monomials that are not alike, right? We just stated that. So if we add this, what would be my answer? Now we could do it horizontally or we could do it vertically.
Vertically.
So 17.
Because it's easier and you can see the signs.
There you go. And then we're adding, and then this is a negative, right? I'm just going to put parentheses here so everybody understand that that's negative 9x to the third plus 10x squared minus 5x. So if I have that, since I have like terms, what's going to happen with the one that has a power of 3? What's 17 minus 9, people?
8x cubed.
There you go. Now I have the same value here, and I'm subtracting the same value. So basically these cancel out, right?
Yes.
They go bye-bye. And then I have I have $1, but I take out a loan for $5. So in reality, what do I truly have?
Minus 4x.
There you go. All right, so this is I believe I did this example, or I did something similar to this when it came to the addition. What about for the subtraction? Let's give an example of that. Subtraction. So now for subtraction, I'm going to give you this similar 6m to the 4th minus 11m squared plus 21. And I am going to be subtracting this, but I'm going to put a parentheses here because I have to account that the negative outside changes the signs for the parentheses. So I have m to the 4th minus 6m squared plus 35. So what happens with this negative that's outside here? What does that do to all of this?
We just pretend it's a -1.
That is correct. So then that's going to change. That's going to change these signs, right? So that positive is going to be a negative here. This is going to become a positive, and that's going to become a negative. So now it becomes like an addition problem, right? If I have negative 6m and I have negative m to the 4th, what is that going to give me? I have
negative 7.
That's
m
right, to
4.
the 4th. And now I have negative 11m squared plus, not negative 6m squared. So if I owe somebody $11 and I'm paying back 6, how much do I still owe them?
Negative 5.
Negative 5. Exactly.
Squared, sorry.
And now, correct. So now I have 2. Actually, this should have been a 21. 21 up here, not a 2. 21 minus 35. So what's this final value here? Is it going to be positive or negative?
Negative 7.
Negative 7?
You got positive 21, and the sign changes as a negative.
Right. So I got negative 35, and I have 21. So isn't that 14?
Yes, of course. Sorry.
Yeah, no problem. No problem. It's all good. I'm just checking. I was like, maybe I'm doing my math wrong. You know, a lot of stuff is going on in the world. The Queen has been buried. Puerto Rico's underwater. I hope everybody's okay over there. If you have any friends and family, you know, hopefully is everything all right.
Yes,
but yeah, but Fiona is no joke. No joke whatsoever. So be very, 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 very careful. All right, so let's keep going with some of these examples. And then the next one I want to continue with would be multiplication. So now, if I have 4t minus 5 times a trinomial, which in this case is 3t squared minus 2t plus 7. And we do it vertically so that way it becomes easier on the eyes. So we write this as 3t squared minus 2t plus 7. And that gets multiplied by 4t minus 5. How would we start this? Any ideas? 12t cubed. Wouldn't we start with the 5? Wouldn't we start with this one? Right, because we're going to be, this is multiplication here that we're doing, right? So negative 5 times 7 is what? Negative 5 times 7 is what?
35.
Negative 35.
Negative 35.
There you go. What's negative 5 times negative 2t?
Plus
Positive 10t.
Positive 10t. What's negative 5 times 3t squared?
Negative 15t squared.
There you go. So now I just finished with the negative 5. But now I have to continue with what? I have to continue with the 4t. So now the 4t, I'm going to change colors. I'm going to use purple. And I'm going to take 4t and I'm going to multiply times 7. What am I going to get?
28t.
So we're going to put that right underneath, right here. like terms. Then 4t times 2t.
Negative 8t squared.
There you go. And then lastly, but not, but, you know, we're not going to leave this for last. 4t times 3t squared would give you what?
4t cubed.
That would be positive 12t to the third, right?
Right.
All right, and that's totally separate, all right? That there's nothing up here that will match that. So we're going to bring this down. What color? Let's say blue. So I'm going to bring this down. I'm going to add it, right? So I'm going to bring this down. So this is negative 35. 10t plus 28t is what? 38t. Very good. And it's positive because a positive and a positive. And then I have negative 15t squared plus negative 8t squared, which means I'm basically, I owe somebody $15 and I take an additional loan of $8. So now I owe them negative 23 squared, correct? Whoa, negative 3t squared. And then this is all by itself. So this is just going to come down and it's going to be positive 12t cubed. And that's it. This is my final answer. So this is how we do multiplication. Okay. Now, this is where I wanted to come and start division, because division is a little tricky. And stuff that's tricky, I like to do simple stuff first, right? Because if you understand simple stuff, you're gonna understand tricky stuff. I hope you guys agree. So if we have let's say 12 divided by 3, what do you get?
4.
4.
Right? And this is the same thing as saying long division. 12 divided by 3 will give me 4. The remainder is 0. And I still get the same answer, right? And you guys are probably like, yo, professor, come on, really? You're insulting my intelligence here. You know, like, what's going on? Like, why are you doing this to us? Well, I want you to understand the concept. And then now we could get into the nitty gritty. So if we have something like, let's see which problem I'm going to give you. Something crazy. Something crazy. Let's see what I can give you. If I give you 12n to the third plus 11n squared plus 5n minus 8 gets divided by 3n plus 2. Well, that's a serious problem, right? That's a serious problem right there. But in reality, it's very similar to the 12 that gets divided by the 3. You just got to do what Sun Tzu did in The Art of War, divide and conquer. And if you're able to do divide and conquer, then you're definitely going to be okay. So you have to say to yourself, right? This is you thinking and saying, well, I have 12n to the third, and I have 3n, right? That's very similar to the 12 divided by 3, right? What do you think that's going to give you? 12 divided by 3.
4n
4.
squared.
So now that you took care of the 12 and the 3, now you have to look at the variable, right? You have n to the third and we have n. And remember, rules of exponents are when you are dividing, you are subtracting, correct? So you're literally reducing 3 by 1, right? There's a 1 here. So 3 minus 1 is what?
2.
It's going to be 2. So if we write this in long division, we already know what the value will be, right? And what is that value? Well, the value that I'm going to use is, I'm going to change the color so everybody can see what I'm adding here. I'm going to use 4n squared. So I'm going to take 4n squared, right? And I'm going to multiply that times what? I'm going to multiply that times the 3n that I have here, because I just did the division, right? And I'm going to get what? 3 times 4 is going to give me 12, right? And then n times n squared is going to give me n to the third, correct? So what do I do next? After I do that, then I multiply the 4n squared with the 2. So what do I get with that? Well, 4 times 2 is what?
8n squared.
There you go, 8n squared. So I'm going to put this in parentheses, and I'm going to put a subtraction sign here. And I'm going slow here, but I want you to see what's happening. Because I have a negative outside, that's going to change this sign here. This is going to become a negative. And this is going to become a negative. Because they're both positives, right? And if I have 12n to the third and I subtract 12n to the third, then this is going to cancel out. But now I have 11n squared, right? And minus 8n squared gives me what? If I have 11 units of something and I give away 8, how many units do I have left?
3n squared.
That's right. So I have 3n squared. I bring down the 5n, just like in regular long division. And now I do the same thing that I did before with the 12n to the third, right? But now I'm doing it with the 3n squared. So now I have 3n squared divided by 3n. What do I get? I'm going to get n, because these are going to cancel out. And I have 2 of these and I have 1 of those. And when I subtract them, I'm going to get 1n. So now I know what I'm going to put here. I'm going to put an n here. And what's going to happen with that n? Well, that n is going to get multiplied with the 3n. And what am I going to get? I'm going to get 3n squared. And what am I going to get when I multiply that n with the 2? I'm going to get what? I'm going to get positive 2n. And now I subtract. And what's going to happen with these signs? Well, these signs are going to change. This is going to become a negative. And then this is going to become a negative. Right? And now I add them. They cancel out. And then I have 5 n's. And I give 2 n's away. What do I have left with? I have 3n. What am I still have to work with? I have to work with a negative 8. I bring it down. Last but not least, I have 3n, right? That's what I'm working with here. And then that 3n gets divided by the 3n outside. And what do I get? This cancels out, and I'm going to get a 1 here. So I know that I'm going to use a 1 here. And I'm going to change colors. I'm going to put it to green. And that 1 gets multiplied with the 3n. And I get what? I get 3n. And the 1 gets multiplied with the 2, right? And I'm going to get what? 1 times 2 is what? 1 times 2 is 2. And then again, I'm going to put this in parentheses. There's a subtraction sign outside. And again, I say to myself, if I have a minus sign outside the parentheses, it's going to change the sign. This is going to become a negative. And then this positive is going to be a negative again. That's going to cancel my 3n. And I have 8, I have minus 8, and I have minus 2. What's going to be my remainder? My remainder here is 10. And how do I write this answer? Well, my final answer here is going to be 4n squared plus n plus 1 with a remainder of what? 10 over 3n plus 2. This is my final answer. This is my remainder, okay? This is my remainder. This is my final answer with a remainder. So this is division. So I take a very simple concept of division. Did I put negative 10? Oh, yeah. Thank you. Negative 10. I appreciate that. See? Someone's paying attention. There you go. That's my remainder. Thank you so much. I really appreciate that, Ms. Pierce. So you take a very simple concept of 12 divided by 3, which is 4, and you expand it here, but now with variables. And these are monomials, right? These are my leading monomials, right? When I'm doing my division. And I see that I get my answer, right? And you see what I got? I got 4n squared, I got n, and I got 1, which is what I have here. 4n squared, I got n, and I got 1. You need to practice this because you're going to get this on your midterm. Any questions regarding this? I hope you've been practicing your homework, understanding this. This is very important, important.
Professor?
Yes.
I mean, I got to solve it in the end, but after a few tries, it's a little confusing sometimes when one term is missing. Let's say they go from the square to the number. Also, I have an example if like it's
you could show me after class. That would be great.
All right, good.
And then that way we could go over it together. So that way we could continue right now, but don't forget to see me after class.
Okay, no, thank you.
Yes, I really appreciate that. And I'm glad you're looking at it, and I'm glad you're taking notes, because that will make the difference later on. And especially when you see me after class, I expect everyone to have questions. And I highly encourage it.
Can we please do another one?
I'll definitely do another one towards the end because I want to move on to the next topic.
Oh, okay.
So that way everybody gets covered as far as greatest common factor, and we can complete factoring, and that way everybody's on page. And then towards the end, I'll revisit that. So we're gonna have, let me write that here so I won't forget. I'm gonna put that in red. Actually purple, I'm gonna put it here. So we have some questions on division. All right, so we'll come back to this. That means in Spanish, look out. All right, no problem. So it's just a friendly reminder to myself. All right, so now we're gonna do some greatest common factor. And this is like the beginning of factoring. We did some of this earlier. I believe last time in class we did this when we had class. We mentioned what the greatest common factor was, and I'll give you an examples to refresh everybody's mind. So in this example, we're going to use 6a squared minus 18a to the fourth. So now we know we have two monomials. We have a binomial here, and we want to take a look at the 6. We want to look at the 18. And the other thing that we want to look at is the base, right? We have an A here and we have an A here. So what number goes into 6 and 18? The highest number. What's the highest number that goes into 6 and 18?
6.
There you go. So I'm going to put that in here, 6. And then now that I'm done with the numbers, I'm going to look at the variables, the base. What is the lowest base that I could use here with a degree?
Square.
The square, right? So it would be a squared. Because if I start off with a to the fourth, does a to the fourth go into a squared? The answer is no. There's just no way. But a squared does go into a to the fourth. All right, cool. So essentially, it's sort of like doing division because we're extracting out that common factor, right? The greatest common factor here. So if we have 6a squared and we put a parentheses here, what are we going to get here? We're going to get a 1. Because if I multiply this, don't I get myself back?
Yes.
Yeah, most definitely. Since I have a negative here, and this is a positive, right? The 6a, this has to remain a negative in order to keep the sign the same, right? Because if I leave it, if I put this as a positive times a positive is not going to give me a negative. So you have to be very careful with that. This will get you some wrong answers. So you want to keep the same value, negative. So now, if we do the same division that we were doing before, what am I going to get here? I'm going to get a 3, and I'm going to get what? 3a squared, right? Because 18 divided by 6 is 3, and a to the 4th divided by a squared, right? 4 minus 2 is, remember, it's 2. We keep the same base. So how do we test this to see if I'm right? Well, we multiply it out, and we are supposed to get the same answer. Do we get the same answer? Six a squared times 1, do I get 6a squared back? And 6a squared times negative 3a squared, do I get negative 18a to the 4th? Yeah, I definitely do. Very good. So this is a very simple one, but can it get crazy? Yeah, it could get crazy. Let's do a crazy problem. So let's do this problem here. We got 14x to the 3rd y squared minus 28x squared y to the 3rd plus 21x squared y squared. You're like, what the hell? Un chorizo, un chicharrón. This is crazy. This is lasagna with some heavy duty ground beef here. This is a little greasy. So what's my greatest common factor? I'll give you like 2 minutes for you guys to look at it. And then I'm going to pick on somebody from the class. I'm going to be like, yo, so what's up, what's up, what's up? What do we got here? What do we got here? So I'll give you like 2 minutes. See what you got. Bonds is like 7. Okay. That's a good try. What else? What
Wait,
about
you want the variables next to the number as well?
What about the variables? You said, someone said 7, but what about the variables?
X squared and y squared.
Okay, that looks good. So now 7 goes into 14 how many times? Fourteen divided by 7 is what?
2.
2. There you go. And then if I subtract 3 from 2, I'm going to get what?
Only x.
Right? So I'm going to get x. And then y squared with y squared is going to give me what? They're going to cancel out, right? It's going to be a 1, right? All right, so that's cool. So now what comes after? -28. Negative 28 divided by 7 is what? Four. Good. And then I have x squared divided by x squared. That's going to cancel out. And y to the 3rd with y squared, what happens there? Y. Very good. And then the last term, I'm going to have a positive here. Let's change colors so everybody can see what's going on here. 21 divided by 7 is what?
3.
3. Oh, I don't know what that is. That does not look kosher. That does not look halal. Oh, that's 3. And x squared divided by x squared is what? Is 1. so we don't count that. And then y squared divided by y squared is 1, so we don't count that either. So my final answer, right? My final answer is going to be what? It's going to be the following. It's going to be 7x squared y squared, because that's my greatest common factor. And I'm going to get a trinomial, 2x minus 4y plus 3. That's my final answer right here. Is this hard? No, you just got to practice. You just got to practice. Can it be tricky? Oh, yeah. Math can be very tricky. Very tricky, very tricky. That's why you got to, you know, got to take your time, practice, make sure everything's good. So you don't fall into any traps or anything like that. All right, so now is this all we got to know about factoring? No, definitely not.
I have a question.
Yes.
Have we done completing the square yet or no?
Completing the square? No, not yet.
Okay.
No, not yet. So we're gonna continue. We're gonna continue with factoring. And factoring, the easiest way I can show you factoring is based on terms. Factoring based on terms. And you're like, what does that mean? Well, if you have two terms, then there's different rules. And if you have three terms, there's different rules for that. And if you have four terms, there's different rules for that. So let's use the easiest one so far. If you have four terms, we will use grouping. And you're like, what do you mean grouping? Like, how does that work? I'm glad you asked. Sorry, my dogs are getting excited with the factoring. Like, yeah, I understand what grouping is. All right. So r squared s plus, that looks like a 5, but it's an s, 3r squared minus 5s minus 15. So now if we're going to be using grouping, what goes, well, before I say that, let's take a look at the grouping. We're going to change the color and we're going to rewrite the problem so everyone can see what's happening here. And I'm going to put some parentheses around stuff. If I put a parentheses on the second term that I just did, and I take out that negative, what happens to the negative in front of the 15 on the second term?
Becomes a plus.
It becomes a positive. So let me say that again. We start off with 1, 2, 3, 4. That's a polynomial right there on the top because we have four terms, right? We have one term, we have two terms, we have three terms, we have four terms. We're going to use grouping. And because we're using grouping, we're going to put parentheses on the first two terms. And then we're going to do another parentheses on the last two terms. But then we're going to put the parentheses right after that operational sign. And in this case, that operational sign is a negative. And if you do that, by you taking out that negative, you're going to change the sign for the last term. Because if I don't do that, in order for me to get the same negative, this has to become a positive. Because a negative and a positive will give me what? A negative. And a negative and a negative, if I leave it, will give me a positive. Do I have a positive up here? No, I do not. So this is why it's so important to change the sign. Because if I multiply a negative times a positive, then I'm going to get that negative back. So you're extracting a -1 out of the equation. So let's keep going. I'm going to rewrite this so it makes it nice and clean. And now I have that equation right there, those two terms. What do you see that I can extract out of the first parentheses, the first term that has those two monomials? What would be the greatest common factor there? Do you see it?
R squared.
Yeah. We're going to take that R squared. I'm going to put parentheses here. And I'm going to be left with what? I'm going to be left with S plus what? Plus 3. Now, what can I do with the second term? What can I factor out of that second term? What can I do with that 5S plus 15? What can I take out of there? Just like I did with the R squared. Yeah, I could do a 5. So I'm going to take out the 5. I'm going to end up with what? I'm going to end up with S plus 3. There you go. And the reason why I'm using color is for you guys to see what is coming out. All right, I'm not done yet. I have to group, hence the term grouping. I'm going to group this. So what am I grouping here? I'm going to group R squared and negative 5. I'm going to group them together. And even though I have 2S plus 3s, I'm only going to put 1. This is my final answer. And you're going to be like, yo, wait up. How do I know that is true? How do I know that's true, Professor? Like, seriously, come on. Well, there is something we use: first, outer, inner, last. So what does that mean? First, outer, inner, last. So if we rewrite this, right? R squared 5 S plus 3. So first, R squared. I know some of you have seen this before. R squared times S is what? R squared S. What is R squared times 3? It's positive 3R squared. That's first. And then now I'm going to multiply my negative 5. Negative 5 times S is what? It's going to be negative 5S. Negative 5 times 3 is what? Is negative what? 15. So now, if I rewrite this without all this color stuff, I'm going to have R squared S plus 3R squared minus 5S minus 15. Is that what I started off with? R squared S plus 3R squared minus 5S minus 15. Yep, it's right here. So this is how you test your answer. So again, remember, when do you use grouping? How many terms do you need to have? You need to have 4 terms. You need to have 4 terms in order for you to use grouping. All right, let's continue.
Oh, Professor,
So now,
I'm so sorry.
Sure.
On the final answer, you don't put a sign between the groups, the groups. Oh, it's a multiplication. Oh, it's okay. It's
where did you get lost?
No. Then you did like 3 square negative 5. But it's a multiplication. It's not plus or minus.
Right. We're multiplying R squared
Yeah.
when we're doing the first, outer, inner, last.
Okay. I'm sorry. Yes, I got
No, yeah, no problem. It's good. It's a good question. So R squared gets multiplied with S.
Yeah.
So that's how we got the first one.
Yeah, no, I get that. The only thing is like what is between the grouping. Like it's no subtraction or addition. It's like it's always like a multiplication.
Multiplication, yeah.
Yeah. Okay.
In this case, because now we got two terms. And how do we get those two terms? So here we got two terms, right? And how do we get those two terms? We got those two terms by grouping.
Uh-huh.
In this case.
Mm-hmm.
And then that grouping is multiplication.
Okay.
Yeah.
Yes. Okay. Thank
I'm
you.
gonna erase this because we're gonna have some stuff coming down. But it's good. It's good. It's good. It's good stuff. All right. So now, what happens when we have two terms? Well, there is something called difference of squares. And we also have something called difference of cubes. All right, so difference of squares, what does that mean? That means you have a square, right? And you gotta have a perfect square. So in this case, the rule says a squared minus b squared is essentially saying parentheses a minus b times a plus b. You're like, okay, hold on, professor. I don't follow this. Like this is a lot of jargon here. So let's say we have x squared minus 9. Is 9 a square?
Yeah.
It sure is. So if we're going to factor this, well, my a is going to be what? My a is going to be x. And what's going to be my b? My b is going to be -3, right? And then here I'm going to get x again. And here I'm going to get a +3. And you're like, okay, so how'd you get that? Well, a is x, b is 9, right? But b squared is 9, not b. So what number times itself twice will give me 9? That's why it has to be a perfect square. One number times itself gives me 9. It's 3. So that's why my b term is 3. So when I factor this out, because this is the rule on top that I'm giving you, I'm going to get x minus 3 times x plus 3. And how do I test this out? How do I test this out? Well, I'm going to multiply x times x. I'm going to multiply x times +3. So I'm going to get x squared plus 3x. That's the first one. And then I'm going to multiply -3 times x and then -3 times +3. And what is that going to give me? That's going to give me what? -3x minus 9. What happens to the +3x and the -3x?
Cancel out.
Cancels. So my final answer is x squared minus 9. Did I get myself back? I sure did. I sure did. So you have to know the rules. You have to practice the rules. When you get a problem like this, the first thing that should be going through your head is this a perfect square? And the answer is yes. The next thing is, how many terms does it have? How many terms does it have? It's going to have 2 terms. All right. We're going to be working with 3 terms in a minute, but we're not done with the 2 terms. Okay. Now we're going to do difference of cubes. Well, before I do difference of cubes, hold on. Before I do difference of cubes, does the following exist? So I'll give you the example. X squared plus 9. Does that exist? And the answer is no. This does not exist. Because when you try and factor this out, you're not going to get yourself back when you multiply yourself back. You, remember with math, you have to get your answer back when you prove it. And this will not bring you back the same answer. So if you get a problem like this, you're going to write no solution. Does not exist, right? D and E. I could give you that. That's valid. And you better not factor this. So you need to understand the rules. All right. Your silence confirms it. All right. So now we're going to try cubes. Let's do the cubes. So now we have two rules. The first rule for cubes, well, we're going to do sum and difference of cubes. The above here was the difference of cubes. That means you could only have subtraction. The difference means subtraction, okay? So here we have sum and difference, but we're going to start off first with the difference, okay? So the first rule says a cubed minus b to the third is equal to a minus b, parentheses, a squared plus ab plus b squared. You're like, what the hell? What does that mean, professor? What does that mean, professor? I'll tell you what that means. So let's say you have x to the third minus 8. Is that a cube? What is
Yeah.
the value of b? So let's work it. Let's work it out. So a is what? What's a? A is x. What is b? B is not 8. What number times itself 3 times gives me 8? 2.
2.
There you go. So now I already have the ingredients to make sancocho. So if a is x, so then this is x squared, then this is plus what? This is plus x2, but we don't write it as x2. We write it as 2x, okay? And what is my b? My b is what? 2 squared, which is 4. So let's rewrite this. So I have x minus 2, x squared plus 2x plus 4. So this would be my solution when I'm factoring x to the third minus 8. Well, let's see. I don't know. Is that true? How do we test this out? How do we test this out? We just did it before when we were testing it out previously. Didn't we do something like this? So how do we test this out? How do I know I have this correct? Multiplying it. Okay, so negative 2 times x squared is negative 2x squared. Negative 2 times positive 2 is negative 4x. Negative 2 times 4 is negative 8. And then I continue with the x. X times 4 is positive 4x. X times 2x is positive 2x squared. And what is x times x squared? That's x to the third. Do you see something here that can cancel out? Yep, these two cancel out. And what is my final answer? X to the third minus 8. Did I get myself back?
Yes.
I surely did. This is what is expected of you on the midterm. You need to understand this. You need to understand it. You need to understand it. So now I'm not going to make this more complicated than it is. We're going to use the same example, right? We're going to use the same example, but we're going to, instead of using difference, right? Because this is difference, right? This is the difference. We're going to use sum. We're going to use the sum of cubes. So what is the rule for that? Well, the rule for that is the following. A to the third plus B to the third is equal to A plus B times A squared minus AB plus B squared. Now, I don't know if you notice, when it's the difference right up here, and this is negative, the middle term is what? The AB in the middle for the trinomial is what? It's positive. And when it's positive here, the middle term is what? It's the opposite, right? So that's one way for you to memorize this, so you don't get confused, because you're not going to be given these formulas out. You need to understand them. Okay, so we're going to use the same example that we just touched on. So we're going to have x to the third plus 8. Okay, so again, what's my A and what's my B? What's A? We just did this.
Yeah. A is X.
A is X. What's B?
2.
There you go. And since A is 2, since A is X, so then I'm going to have X squared here. I'm going to have minus X. What's B? That's 2. What's B? That's 2 squared. But I don't write it this way. Well, it's not that I don't write it. It's not written this way. So you're going to write minus 2x, because you put the variable first, plus 4. So your final answer, when you factor this out, you get x plus 2 parentheses. Then you have a trinomial, which is x squared minus 2x plus 4. And this would be your final answer. How would you test for this?
Multiplying.
You would multiply it back, right? Correct. So you would have x squared minus 2x plus 4, and then you would multiply times x plus 2. And then when you do all this crazy math, your final answer will be x to the third plus 8. I'm not going to do the multiplication here because I already did the first one. You guys can entertain yourselves doing that. I want to continue. All right, let's keep going. So I told you we're going to get into the nitty gritty. Now we have 3 terms. 3 terms. So we're going to be using the ones that are most common here and the ones that we're going to use mostly. So the one that we mostly use when we have 3 terms is when we have a trinomial, right? And that trinomial would be x squared plus bx plus c, whereby if we have x squared plus bx plus c, then when we factor this out, we would have 2 x's. And by having 2 x's, depending upon if the sign is positive, if they're both positive, then both of these would be positive. If the signs are different, then we would look at what values we could use in order for us to get this term here. So let me get some examples for you for this. It's a lot of practice. A lot of practice. Trying to get you a problem here. Sorry that at the beginning of the semester it's a little dry. The stuff is a little dry. There you go. There you go. Here's an example. So we have a squared plus 5a plus 6. So this is a very easy, basic problem. First of all, does it have 3 terms? That's the first question. The answer is yes. Since it does have 3 terms, then we know we're going to be using the rules for factoring with 3 terms. We're not going to be using grouping, and we're not going to be using difference of squares, and we're not going to be using sum or difference of cubes. So we're going to be using the rules for 3 terms. Here, we would take 2 parentheses, and since we have 2 A's, they go here. The next thing you want to do is you need to determine what are the value for the signs. And what value are they? Are they both positive? Are they both negative? Is one negative and the other one positive? This is like the easiest one. They're both positive. So since they're both positive, so they're both positives. And then we got to figure out the last one. So this is what I do in order to do this kind of problem. What 2 numbers when and it has to be the same 2 numbers, okay? You can't use 2 numbers for addition and you can't use 2 other numbers for multiplication. It has to be the same 2 numbers. So what 2 numbers, when you add them together, gives you 5, and when you multiply them, gives you 6. And it has to be the same. So Ms. Pierce says, and Scarso says, +3 and +2. And you guys are correct. There's going to be +3 and +2. Does it matter which one goes first? Not really, but I'm going to put the lowest one here and the highest one here. Can I put the 3 first? Yes. Can I put the second after? Yes. It's not a problem. So how do I know if this is correct? I mean, how do I know I'm just making this stuff up? Well, you're going to test it out, right? A times A times 3. Then 2 times A, and then 2 times 3. Let's do the first one first, right? So A squared plus 3A. Then 2 times A is 2A. And then 2 times 3 is 6. So when I add this together, I'm going to get 5A. Remember, 5A, not 5A squared, 5A. Because there's a 1 here and there's a 1 there. When I'm adding powers, what happens? Well, I'm sorry, when I'm multiplying bases, I'm adding what? What am I doing with the powers? I'm adding them, right? So 1 plus 1 is 2. But that's if I'm multiplying them. But am I multiplying them or am I adding them? I'm adding them. So I don't do anything. So here I get 5A plus 6. Did I get myself back? Is A squared plus 5A plus 6 the same thing which I started with?
Yes.
You guys are playing hooky with me, some of you. Okay, very good.
I have a question.
Who's that? Who's that?
Elizabeth.
Hey, Elizabeth, que pasa contigo?
Struggling because when I get one problem, then the next problem is it's just
okay.
What I'm confused is about that you get a common number that adds the 5A but multiplied by 6. I didn't know there was rules to that.
But this is the most basic one. Wait till we get to the other one. But
oh my God,
you know where this is going, right? It's not getting more easy.
Oh my goodness! I literally spent hours.
I know, but I'm not gonna break you. I'm not gonna break you. But I do have to teach the rules, and then I might give an example of one on the midterm here and there. But I'm not gonna break you. All right, but we're not done with.
Sorry.
I'm sorry, go ahead. But you had a
So-
question? You had an example or something? What was going on?
No, so this applies to the term 3, right? That
3 terms. Uno,
terms.
dos,
So-
tres, right here.
so the whatever number is in the middle, it's adding to that number, and whatever number is in the last.
Right. So the middle term, the BX, is getting added, right? Because 2 plus 3 is 5. And then the C term here, which is 6, that's the one that gets the same 2 numbers get multiplied and gives you the C.
Okay.
Yeah.
I'm gonna see you after class. Okay, thank you.
Yeah, no, but we're gonna do a very similar problem now, but it's gonna be a little different. And how is it gonna be different? The signs are not the same. The signs are not the same, and that's how it's different.
Okay.
Because we want to do as many scenarios as possible. So we have y squared plus 8y plus 12. So we do our parentheses first. And then we say to ourselves, well, I have 2 y's, right? So I'm going to put them there. But now I have a negative and I have a positive. So what you want to say to yourself in this example is, if the middle term is the one that you take two numbers and you add them together, and the last one is you multiply them, right? Just like we were just discussing with, I think it was Elizabeth? Yes, it was Elizabeth. We were just speaking with Elizabeth. Elizabeth was saying, okay, so we add the middle ones, and then we add for the middle, and we multiply for the last term. So in a case like this, you're like, well, hold on a minute. The 12 is positive, and oh my God, that one in the middle looks like it's drunk. 8. It took too much tequila. Okay, hold on, or whiskey. 8y. There you go, 8y. That looks better. So what number, when I add it together, will give me -8? And when I multiply it, it's going to give me +12. Now remember, the final answer for addition is negative. So that means that both these values have to be negative, because a negative times a negative will give me a positive when I'm multiplying. But when I'm adding 2 negatives, it'll give me a negative. So just like Simone said right now, Anissa, they got to be negative, both of them. So she said -2. So I'm going to put the -2 here, and I'm going to put -6 here. And let's see if her answer is right. So a negative and a negative will give me a positive when I'm multiplying them, right? I don't know why it gives me a straight line. Will give me a positive, and 2 and 6 will give me 12, right? When I multiply. So that sounds good. And if I take out a loan for $2 and then I go to Elizabeth and take out another $6 from Elizabeth, now I owe $8. So that's the middle term, right? So that sounds good. So let's test it out. Let's test it out if I'm right. So y times y will give me y squared. Y times -6 will give me -6y. So I got that done. So -2 times y will give me -2y. -2 times -6 will give me +12. And that's my C term, right? And then this is my BX. And this is my what? AX squared. But let's just keep it clean here. So this is y squared minus 8y plus 12. Did I get myself back? Yes, I did. I got myself back. So it is correct. So Simone, Anissa, you are correct. You are correct. All right. So now we've seen 2 situations so far. Can I show a different method? I find it easier. Pierce, by all means, however you want to get to your answer, so long as it's the same one and you're not cheating or using a calculator, we're good. We're good. So now we've done both of them positive, we've done both of them negative. So now let's do one that's positive and one is negative. My camera versus my method. My camera. Not right now though. You can show me towards the end of the class, so you can show me. Because I want to continue with the material that we got to go over. If not, we're going to be here until 2024 teaching this class, but it's all good. All right. So in the next one, we're going to have a situation where one is positive and one is negative. So let's do something easy. X squared plus X minus 12. So again, how many do I have? I have 2. What value, when I multiply it together, will give me negative 12, right? So what's divisible here? Like 1, 2.
Positive 4
3.
and negative 3.
Positive 1, negative 3?
Positive 4.
You
and
said
negative
positive 4, negative 3? Okay, let's try that. Oops, why did I write that? Positive 3, negative 3. Positive 4, negative 3. So if I have $4 and I subtract 3, I get $1, which is the X in the middle. And then when I multiply positive 4 times negative 3, I'm going to get negative 12. I think he's right. I think he's right. So X times X will give me X squared. X times negative 3 will give me negative 3. 4 times X will give me positive 4X. And 4 times negative 3 will give me negative 12. So I'm going to get here positive X minus 12. Did I get myself back? I sure did. Holy Toledo. Very nice. Very nice. Very nice. Very nice. All right. So far, so good. Where are we right now? Okay, so it's 7:13. Okay, we're still good. We still are good, 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 good. Let me see what else we're going to get into. Well, we did the perfect squares. I'm just going to give you a refresher here. I'm going to give you a little refresher here. We'll see if you guys remember what I just gave you. I have X squared minus 36. Factor it out.
X plus 6 multiplied by X negative 6.
Perfect. That's going to be your answer. Because when you multiply it out, X squared minus 6X, you're going to get positive 6X, then you get negative 36. These cancel out. You got X squared minus 36, which is the same thing you had before. Very good. Very good. Very good looking. I like that. I like that very much. Difference of 2 squares, difference of 2 cubes. We did that. I want to do we did factor by grouping, and I want to get to the other stuff that we got to do. All right. So I'm going to give you another example here for a trinomial before we move on to bigger and better thing. What would happen if we have, so far, we've been managing with, for instance, the one we just did, X squared plus X minus 12, right? Was there a coefficient here? What's the coefficient next to this X squared right now? The one that we just did. It was a 1. It was a 1, right? So it didn't affect in any way. It didn't affect in any way. But what happens if we have something greater than 1? So we're going to start off easy, and then we'll work ourselves a little bit more complicated. If we have 10x squared plus 70x plus 100, what do you see? What is the first term divisible by? What is the second term divisible by? What is the third term divisible by?
10.
Yeah. So you could say 10 parentheses x squared plus 7 plus 10, right? Because if you multiply 10 times x squared, you're going to get 10x squared.
You
And if you
don't keep the
multiply,
X.
oops.
You don't keep the X from the suddenly. Oh, okay.
Yeah. I'm glad you were looking. You passed the test. So 10 times 7x gives you 70x, and 10 times 10, it gives you 100. But am I done, ladies and gentlemen? Am I done? If I need to factor this out.
No,
No.
because x plus 2 multiply x plus 5.
Mm-hmm. Is that Mr. Langston?
Yes.
Wonderful. So what do you say we have out here? We have x.
X plus 2 multiplied by x plus 5.
All right. So let's try it out. If 2 times 5 gives me positive 10, that's good. And if I add 2 and 5, I get 7. That's good too. So yes, you are correct. So my final answer would be 10 x plus 2. I'm going to put this in a bracket here. And I have x plus 5. Very good. Very good. Very good. All right. So far, so good. So now let's do another one. Let's do another one. Very similar to this one to see if everybody's getting the gist. So I have 10x squared plus 10x minus 120. Mr. Langston, don't say the answer. Let's see if everybody else is following along, because I know Mr. Langston is on fire and he's not watching Hunger Games. Let's pick on someone. Madia, are you here, Madia? Madia. No, Madia.
I am. I was trying to unmute myself.
No worry. So Madia, so from what we just explained earlier, right here in the previous example, what can we do to this problem? It's very similar, right? It's a little different, but very similar as well. What can we extract out? What would be our greatest common factor here?
10. Yeah.
10. Yeah. Let's take out 10. So then I'm going to get bracket x squared plus x minus what? 12. Right? Because 10 times 12 is 120. No? Yeah.
Yes.
So what comes next?
You do grouping.
Grouping? Good try. Good try.
Is that what it's called, or factoring?
We're factoring with three terms. So we're going to have two parentheses, right, Medea? And this x, how many x's do we have?
2.
There you go. And what number times itself will give me negative 12? What two numbers, I should say?
Positive 4 and negative 3.
Positive 4, negative 3. That's right. And there's a 10 outside waiting for them. They're going to get jumped. So people caught on to that, right? X times negative 3. So we get x squared minus 3x. And then 4 times x will give you positive 4x. And then 4 times negative 3 will give you negative 12. And when we add this together, it will give me x minus 12. And I have a 10 outside. Then I distribute the 10. And I'm going to get 10x squared plus 10x minus 120, which is what I originally started with. Guys, is this hard? But it could get hard, right? It could get tricky. All right, so let me take attendance again. But let me do a little recap. So in today's class, we did polynomials, we did addition, we did subtraction, multiplication, we did division, we did grouping, we did cubes, we did quadratics. And we started off by identifying monomials with trinomials and binomials. Then we did an addition problem of two polynomials and we got an answer here. Then we did a subtraction and we got an answer here as well. Then we did multiplication. Then we have a final answer there. After that, then we did division. We did some basic division with remainders. And our final answer for this problem was 4n squared plus n plus 1. Then after that, oh, see, this is why I like doing a review, because we're going to be going over some problems towards the end of class. Then we did greatest common factor, which essentially we're extracting variables and bases that are the greatest in order for us to extract them. And we did two examples of that. Then we did factoring based on terms, not only on a greatest common factor. We did it on 2 terms. We did some for 3 terms. We still have more for 3 terms. And then we have grouping. We did grouping. We give examples of each. And as you can see, this is just keeps going and going like an Energizer bunny. All right. Let me stop recording.